Welcome everyone to week number 5 in Science 200. Realize that we are past the halfway point in the term. So you just have a few weeks left. You have to finish up your paper. You'll be making a set of speaker's notes, which is not as big as your paper, and you'll be making a slide presentation for that last week, and then you will be finished with Science 200. You can have a good winter break, and then you can start back in the new year to continue on with your studies. So you're almost there. All right, let's see what we've got going on. Last week, we talked about your audience. You chose an audience to present to, and then you figured out ways, strategies really, to bring your audience in, get them interested in your topic, and communicate with them effectively. If you don't do this, you may be completely talking over their heads for the whole presentation, and boy, are they going to be upset. Or you may be talking down to them, and they are not going to like that either. So you have to figure out who your audience is and present to them. You may have the highest level of understanding of your topic. That really doesn't matter if you can't communicate your information to the particular audience that you're presenting to. Okay? So scientific communication is very important. Get science across to everyone, and you have to consider your audience. So you guys did that. So this week is about biases in science. We're going to talk about that. Probability values, confidence levels. Gregor Mendel, I want to talk about them. And also the Deepwater Horizon oil spill again. So biases in science. We are human beings as scientists, and we bring bias into the scientific process. But we have to remove it if we possibly can. What kinds of bias? There are all kinds of bias. One type of bias is the researcher's bias. I told you in the beginning that in the scientific process, you start off by really studying your subject. You have to do a tremendous amount of background research to figure out how all of this works, whatever it is that you're studying. So don't you think that you have a pretty good idea of what is going to happen when you set up experiments? Yeah, you have an idea of what is going to happen. Does that always happen? No, it doesn't. And sometimes the greatest discoveries have been made because of these unusual findings that come about. So that's one type of bias, the researcher bias. Also, especially if you're using human beings as subjects, clients, patients, whatever they are, whatever they're called in your study, they can bring a bias. They have volunteered to do this. They volunteered to do your clinical trial because they have an invested interest in this, and they want to help move this project forward. So they have a bias. Well, to get rid of both of these types of bias, we have what are called double-blind studies, where the researchers and your subjects do not know which treatment they're getting. So they can either have the placebo, which is basically nothing. When I did the Pfizer COVID clinical trial, I was given placebo, which was salt water. So placebo is nothing, and then you have the treatment. Well, the researchers and the subjects, neither one know who's getting what until much later in the study. So you have to already be getting results before anybody finds out what is going on. It's hidden, that information is hidden. That removes a lot of bias. Then you have other types of bias, like, well, who exactly is paying for your study? They may want you to have a particular outcome. Are you always going to get that outcome that they want? No, you're not. So you have to consider that, and you have to remove it if you possibly can. You may not have any more research money coming in from them anymore, but that's the way that it goes. All right, a couple of other things that have to do with validation of your results. We look at p-values, and you want a p-value that is less than 0.05. 0.05. So that's 5%, okay? 0.05 is 5%. So what the heck does that mean? a p-value of less than 5%. That p-value means that whatever this phenomenon is that you have observed is 95% of the time going to happen because of what you have determined, and only 5% of the time it happens by chance. And if that thing happens by chance a lot of the time, like 50% of the time, how do you know that your phenomenon is even at work in this particular scientific exploration? So you want that p-value to be extremely low. You want it to be 5% or less. And that's why you look at those p-values of 0.05, or sometimes it's 0.01. So that's only 1% of the time this thing could happen because of chance. On the other hand, sort of the opposite of that is confidence levels. And if you have a confidence level of 95% of the 95%, that means that 95% of the time your thing is happening the way that you're saying that it's happening, and because of what you're saying. So that's confidence levels. The reason that we mention Gregor Mendel in this section is because of the importance of data collection. In science, data is absolutely everything. Science is not full of opinions. Nope, it's data-driven. What we understand is happening is driven by data, and you will always see that in science. Unlike everything else on the internet, which is just opinions that people have based on sometimes absolutely nothing but how they feel that day. Science is based on data. So Gregor Mendel was an Austrian monk, and besides praying, he didn't have a lot to do, and he was interested in botany. So he wanted to plant some plants, and he wanted to study them. Well, there were a lot of farmers who grew peas back then. A lot grow peas now. And there are different varieties of peas. So Gregor Mendel decided that he would study the traits in these pea plants. Because there were lots of varieties, the growth cycle was very short, and they produced lots and lots of offspring. So he studied genetics. And he made all these different crosses between the different pea plants. And he collected the offspring and he counted them. He counted nearly 30,000 different offspring from these pea plants. And he came to a couple of very important conclusions. One was that in each plant, there were two versions of a trait present. So it wasn't just one unit of heredity that had to do with flower color. There were two versions of it in a pea plant. So that was very important. That was before we even knew what chromosomes were, which is very interesting. So he knew that there were two versions of each trait in any organism. And then he also figured out that some of these traits were dominant traits, which means that they were expressed whenever they were present, either one or two copies. And then there were recessive traits that were only expressed if there were two copies of those. And don't you know those terms today? Dominant, recessive traits? Of course you do. You've heard of those. So he was very important in determining a lot of concepts in genetics just by studying pea plants. And another interesting thing is that then he was promoted to an administrator in the monastery, and he never grew any more peas and never determined anything else about genetics. That was the end of his scientific career. But he really contributed to the science of genetics. All right, then you're also going to read a little bit more about the Deepwater Horizon oil spill in 2010 and how the BP scientists were saying that a certain amount of oil was coming up from this broken oil rig. And scientists were saying, that does not sound right. And so they started doing calculations and they said, no. There's about 90% more than what you're saying is coming out of that broken oil rig. And so we've got to use a different strategy in order to shut off this oil that's being pumped out into the ocean water. instead of what you're saying to do. Why is this important? Because scientists are unbiased. The BP scientists, engineers, whatever they were biased. BP didn't want to have this horrific mess on their hands in the news all the time. They wanted to squash everything that was being said about it. And so they, of course, weren't going to say that, oh, their estimate was only a tenth of what was really coming out of the broken oil rig. So anyway, read about that. It is very important and explains to you why scientists are so important to help us understand things. All right, and then the work that you have that's due this week. No discussion boards this week in week 5. You will in week 6 and week 8, but not in week 5. You will revise your rough draft as soon as I can get to grading those from week 4, because that was a big assignment, and this is Thanksgiving week, so it's going to be crazy. I will grade those quickly as I can. But you're also going to add a hypothesis section. Now, here is where you're probably going to have a little bit of an issue, because you developed a question in the beginning, right? I think it was the second week. You developed a question that you wanted to ask, say for electric vehicles. Well, exactly how environmentally friendly are electric vehicles? Or with ocean acidification, exactly how fast is the pH dropping in the ocean? Something like that, right? So you develop these big overarching questions about your topic that you wanted to take a look at through your research. This week, you're going to develop a hypothesis. A hypothesis is a much smaller, more specific question that can be answered with experimentation, right? So if your topic is ocean acidification, you might choose something like, how does the pH of ocean water change as you add more and more and more carbon dioxide above it, right? Can you imagine how you could do this in a laboratory? You could take samples of ocean water, put them in vessels, and then you could pump in different volumes of carbon dioxide into the airspace, and then you can measure the pH of the water and how it changes, right? So that's a testable hypothesis. A hypothesis is a much smaller question that can be used to develop a series of experiments that can be tested. That question in the beginning was a big overarching question that has to do with your whole topic. So that's the difference. Your question in the beginning was big, your hypothesis is small and testable. Use the rubric to guide your work, because that tells you everything that you need to include, which is all the parts from the paper in week 4. Remember, I've said before that this is building your paper as we go. So you're adding more and more and more sections, and you're revising as you go too. So use that rubric to help you. So that's what you've got to do this week. Tip of the week is use your feedback from me to improve your work, especially that box for each graded assignment that I have, the overall feedback. Especially look at that part, okay? That's very important, because I tell you exactly what you need to change. So use your feedback from me to improve your work. With that being said, I hope that you have a wonderful Thanksgiving week with family and friends. If you have to work and you aren't in a place where you can be with family and friends, I'm so sorry, but everybody should be thankful for everything that they have. I hope that you have a wonderful week this weekend. Please let me know if you need anything. m.sigmon@snhu.edu. Have a good week.